Good afternoon everyone. Sorry, good evening everyone. So today is the last and the final session of this course. So I am Chanda Devnath, one of the PMRF fellows of ISR Padhampur, TA of this course named Reagents in Organic Synthesis, instructed by Professor Subhash Chandra Pan from IIT Guwahati. So in this class I have discussed about some questions based on different type of reagents and their applications. So till now in my previous classes I have already discussed about some applications of some important reagents like oxidizing reagent, reducing reagent, hydrogenation reagents, some metal containing reagent, non-metal containing and all. So today's class is a bit miscellaneous. I am trying to cover up whatever questions have been missed. So let's start. So the first question is, consider the reaction sequence shown below and you have to answer the two questions based on that. So the first question they have asked, what is the oxidant X? The second question, what will be the product P? I just give 1 minute, just give it a try. Because till now we have solved all type of question based on these oxidizing reagents. So I hope you may solve this one. So the oxidant, what will be the X oxidant? So first we have to undergo the dihydroxylation and that should be a syn dihydroxylation and one of the OH will be tosylated. So we have to perform a syn dihydroxylation and one of the OH will be tosylated. So dihydroxylation reagents are this osmium tetroxide and this MCBB. Okay, these two are not dihydroxylation reactions. Now the question is, we have to do this syn dihydroxylation because see both are above the plane, so we have to do the syn dihydroxylation. So as MCBB dihydroxylation is go through a epoxide pathway, that first this epoxide will form, then OH will attack here. So in this case always trans dihydroxylation take place. So cis dihydroxylation is always performed by osmium tetroxide. So the correct option is, this is also cut, correct option is osmium tetroxide. Syn dihydroxylation means osmium tetroxide, trans dihydroxylation means MCBA followed by NaOH. If you know about the mechanism, it will be very easy for you to predict. Now the next is they have added a strong base which leads to a elimination. Can anyone try how this? Obviously this OTS will be the leaving group for this reaction. So if you just draw it in a chair form, this is OTS, this is our OH. Your OH. Now for this elimination we need to find a trans bond which will be eliminated along anti-periplanar. There is no such anti-periplanar H with respect to this, but this bond is anti-periplanar to this carbon oxygen bond. Because of that, this OH will come here and this undergoes a ring migration and OTS removed from the system, which leads to a formation of 7 and 5 member ring. So the correct option is option D. So the correct option is option D. So here is the answer. Just note it down. If you want to draw it in a cyclohexane manner, you can draw this one also. Let's go to the next question. This is similar kind of OTS and base is given. So obviously there will be a elimination reaction. For a hint, you have to draw this in a cyclohexane manner. It will help you to solve the question. Just try. So let's draw it in a cyclohexane manner. So you have to find the trans bond with respect to this carbon OTS bond. From the structure, see I have told you if you draw this in a cyclohexane, it will be, question will be very easy for you. So the trans bond is obviously this carbon-carbon bond. So this OH comes here, this breaks and get removed from the system. So the correct option is this double bond, new double bond form, that is where these two carbon are trans to each other, so there will be trans double bond. So only one trans double bond is there. This is this one. All these two are cis double bond. So the correct option is option D. Correct option is option D. Just note it down. The major product formed in the following reaction. So in the last class I have talked about Chugev reaction. In the last class I have talked about Chugev reaction. You remember? So this is a this is a scene elimination reaction by using xanthate ester. By using xanthate ester. So what will happen? This NaH minus will take this proton and this O minus will attack to this CH2 and this will open up and attack to this methyl and one iodine will be removed. So it will form this xanthate ester. Now it will take only the seen hydrogen. So here there is a hydrogen available, but this hydrogen is not seen to this xanthate. So which hydrogen will be involved? This rounded one, and so this will come here. This by elimination, generating this as our product. So correct option is option A. Correct option is option A. let's go to the next question. What will be the major product formed in the following reaction sequence? What will be the major product formed in the following reaction sequence? So you know that in presence of hydrogen peroxide, selenium undergoes oxidation and forms selenium oxide. So this will be oxidized. And if you give heat to this, it will undergo the 1-2 elimination. So the product will be now in presence of heat, Ac2 will be also eliminated. Ac2 will be also eliminated, so this will go here. These double bond shifts and Ac2 get eliminated from the system, generating a diene type of moiety. So now in a single system there is a diene and a dienophile. There is a diene and a dienophile. So it will undergo the Diels-Alder reaction. It will undergo the Diels-Alder reaction, forming a 6-member ring. So this join here, this center join here. The correct option is option D. Correct option is option D. Understood, right? First one is selenium oxidation, which undergoes a 1-2 elimination or scene elimination type of reaction. After that, a cheletropic reaction where Ac2 get eliminated from the system in presence of heat. And lastly is a Diels-Alder reaction. Last one is the Diels-Alder reaction. Let's go to the next question. In the following reaction, the major product X is, so they have asked for the major product formed in the following reaction. So in presence of selenium dioxide, this methylene CH2 group get oxidized after first step, the first thing what will happen, this get oxidized. In the next step, NaOH is given. What will happen? There is a diketone system. So what will happen? So this OH is given. So this OH will attack one of the carbonyl group. Now between these two, it will attack to this carbonyl group. And this carbon-carbon bond shift to the carbonyl compound, and this open up, forming this acid type of acid and OH oxygen minus. Now in presence of H3O plus, it will get protonated, and the correct option will be option C. Correct option will be option C. This is benzyl rearrangement. Just note it down. Let's go to the next question. What will be the major product formed in the following reaction sequence? So in the first, they have given this aldehyde and pyridine sulfonic acid. So obviously then aldehyde protection will take place. In the next page, they have given NaIO4. Which will lead to a ring cleavage, and after that they have given a reducing agent. Just try, then we will solve together. Just give it a try. Okay, so what will be the answer? So first, this 2H group will be protected by this aldehyde. So just draw it in a cyclohexane manner. Always remember, whenever there is an aldehyde, aldehyde always prefers the formation of 6-member ring, whereas if there is a ketone, that always prefers the formation of 5-member ring. So this, whenever there is a aldehyde is given and you have to perform a protection reaction, it will always prefers the formation of 6-member ring. So that is possible if you use these two OH. But if it was a ketone, it will always prefer a formation of 5-member ring. These two will involve forming this cyclized compound. Now if you give NaIO4, it undergoes a ring cleavage from here. Forming this if you give NaIO4 to this, this undergoes a ring cleavage forming a OH bond here. This is first same, and if you which leads to a formation of aldehyde. Now if you add NaBH4 to this aldehyde will be reduced and give us this as our desired product. So what is our correct option? Option A. Let's go to the next question. What is our A and B? So they have asked for what is our A and B. So in case of selenium dioxide, this allylic H CH2 will be oxygenated. So this will be oxygenated. So this will be CHO. The next step, they have added aqueous NaCN MnO2. So if you add aqueous NaCN, Cn minus will attack. Forming this OH. Cn. Now as this is the allylic OH, so this will undergo the oxidation. Now as NME2 is given, this may attack to the center and remove the Cn from the system. So is given. So this NMA2 will attack here and remove the CN from the system. Now you have a question. Now in this system they are already given isopropyl alcohol and amino2. Why not isopropyl alcohol is attacking but amino2? Obviously because nitrogen has better nucleophilicity than oxygen because of less electronegativity than oxygen. So this, and nitrogen has two methyl groups, so plus add effect is increasing the electron density over this nitrogen atom, so which enhances the nucleophilic property of the nitrogen atom. Because of that, it's attacking to the carbonyl center and removing CN from the system. So what will be the major product formed in the following reaction? They have given 3 reagent and asked for the product formed in the following reaction. I just give 2 minutes, just give it a try. So for the first step, I will just give a hint. This is this. So this acid OH can attack to this carbon center and remove one OMe from the system. what will happen? This acid group, acid OH will attack to this methyl carbon center and remove the OMe from the system, generating this as our product. After that, what will happen? So the BH3 is given in between ester and acid. BH3 is selective to acid. I have already taught in the previous classes what I have discussed about reducing reagents and their variety of reducing agents and their selectivity to different type of functional group. If you want to know, you can go to the check the first 3-4 classes. You can get an idea. So this will reduce this acid forming this CH2OH and that will attack to A and remove this from the system. So the correct option will be option C. So the correct option will be option C. So after that, this OH will attack here. Remove this from the system. So the correct option will be option C. The major product formed in the Beckmann rearrangement of the compound given below. So what will be the major product formed in the Beckmann rearrangement? So we know Beckmann rearrangement is always a trans elimination. In case of Beckmann rearrangement, always a trans. So this TS will be, OH will attack to this TS tosylated to form a good leaving group. After that, whichever is the trans bond, that will be eliminated. So here from the structure you can see this chiral center carbon is the trans to this nitrogen OTS. So this center will come here and OTS will be removed from the system. So this reaction goes through like this. So as this is trans, so this anti-migration, this will come here and OTS will be removed from the system, generating this. After that, this nitrogen lone pair this will come here forming this alkyne. After that, if you add water, this water molecule will attack to this center and open up. After that, through elimination of OH, it will give this as our product. So correct option is option C. So by this Beckmann rearrangement, we can get amide from imine. We can get amide from this hydroxyl imine. Okay. I hope it's clear. Let's move to the next question. This is also based on this Beckmann type of rearrangement. So just give it a try. We have already solved one question based on this Beckmann rearrangement. Just give it a try. So in the following reaction sequence, what will be the major product? So this is a aldehyde, a ketone. So this ketone will form a hydroxylamine type of reaction with this hydroxylamine. It will form this type of NOH after that if you get a tosyl chloride, this will be tosylated. The other part will be just intact, only this part is reacting. Okay. So after that, if you add heat, this trans double bond will be shifted. Here methyl and this is trans, so this will shift to this nitrogen, forming this nitrogen cation. After that, if water attacks, it will form this amide. So the correct option is option A. Okay, so from the Beckmann reaction, what you have learned? Always a anti-rearrangement. Always the anti-bond will rearrange. Always the anti-bond will rearrange. Why not this? Always the anti-bond will rearrange and giving a amide. The product will be a amide. What will be the major product formed in the given reaction? This is also famous name reaction. If you heard about Hofmann degradation, anyone has? In my class, I don't know, I don't remember actually. It is, I have taught it or not. This is Hofmann degradation. Yes, in one of my class I have already discussed about this. So whenever there is a amide group, just remember, in case of Hofmann degradation, from amide you will get a amine. So you want to remember through a shortcut, this is like this. But you will solve it by a mechanism. I am just for a simple idea, from amide you will get a amine in case of Hofmann degradation. That's why it's called degradation, because number of carbon is decreasing. So that's why it's called Hofmann degradation. So let's start. So this NaOH is given, so this OH minus will attack and this will open up. Sorry, this will open up. Forming a acid amide adjacent to each other. Now as it is in the system, and as what I told, in presence of Hofmann degradation reagent, amide will transfer to amine. So the correct option is option A, because this amide will transfer to amine. So the correct option will be option A. That's simple. Understood, right? First OH minus is just leaving the five-member ring. After that is just a Hofmann degradation reaction. There is another question based on Grignard catalyst. So let's try to solve this one. So in the first step, they have given dival H. So you know the dival H is used to reduce ester to alcohol. if you add one molecule of dival H, if you just consider this as H minus, this one will attack here and it will open up. So this Grignard will attack to this carbon in the center. Next, if you add PCC, both the OH will be oxidized as there is a H available here. So this will also oxidize, and as there is a H available here, so both this CH group will be oxidized and giving this as our desired product. So the correct option will be option A. Both of these will be oxidized. Understood? Let's go to the next question. So among the following, what is the correct statement for the following reaction? So they have given this Grignard reaction and two product has been shown. So what is the correct statement? So let's read one by one. A is the major product and it will have 5 signals in proton decoupled 13C. So there is a 5 type of carbon. There will be 5 type of carbon. A is the minor product and there is 8 type of carbon. B is the major product, 5 type of carbon. B is the minor product with 5 type of carbon. So first we have to determine between A and B which one will be the major product. I just give 2 minutes, just try by yourself.
compounds of this dehydrating agent. So H3PO4 will give a H plus. We take a H plus. So this will give a more substituted double bond. So this will be the major. So A is our major product. A is our major product. So A is our major product. And number of 13C carbon. Here number of 13C carbon is 1, 2, 3, 4, 5, 6, 7 and 8. So number of carbon is 8. So there is no such option like this, whereas the minor is this one. Number of carbon is 8. So B minor with 8. Oh, sorry. Now see, in this case, the compound becomes symmetrical. So these two carbon are same. So 1, 2, 3, 4, 5. So number of carbon 5. So B minor with 5 carbon. Is there any option like this? B minor with 5 carbon. B minor with 5 carbon. So correct option is option D. Did you understand? Whatever the types of carbon determines the number of 13C signal. If there are 5 different types of carbon, it will show 5 peak in 13C. As this here two carbons are in a same are symmetrical because of this plane of symmetry. So these both two, there will be one signal for these two carbon, one signal for these two, and one signal for these two, one for this one and one for this one. Okay. In the following reaction sequence, the structure product form. So they have asked for the product structure here. Just give it a try. So in the first step they have given divalage. So divalage will just reduce. I'm just showing this thing. Okay, I'm just showing this ring, because this ring will be intact. So it will just reduce this alpha beta unsaturated ketone. So what will be the answer? So it will just reduce this ketone. So there is two type of probability. One, this H minus is coming from the below the plane. Another is H minus is coming from the above the plane. So there will be two types of product is possible. One is above the plane OH and that is below the plane OH. But as this, if you just imagine this structure in a 3D way, structure is like this. These two 5-member rings, because both the H are below the plane. Both the H are below the plane. Both the H are below the plane, so structure is like this. Because of that, because of this congested stereochemistry, the above the exoplane is bit crowded. So this side attack is not favorable, whereas the H minus will attack from the below the plane. H minus will approach from the below the plane. So H minus will approach from the below the plane, giving this as our product. Next step, if you add LiLH4, what will happen? So our correct option is option.
Identify the major product X in the following reaction. Just give it a try, then we will solve it together. Identify the major product. So first, so in presence of TiCl4 can act as a Lewis acid. So in presence of TiCl4, this Cl minus will add, then it will form this carbocationic species, where this SiMe3 goes here and attacks from this center. So the correct option is option C. So the correct option is option C. So whenever there is a SiMe3, it always attack from this allylic position. Whenever there is a Si, because carbon silicon bond is very prone to break, so it attacks from this allylic position. Whenever there is a SiMe3 group, you will, if like aliphatic SiMe3 group, try to go through like this pathway. So this much for today's class. Thank you everyone. I hope you have enjoyed each of the classes, and it may help you to get an idea about reagents in organic synthesis. So all the best for your upcoming examinations. Thank you.